Hey, welcome to my channel. I'm super excited for my second video and hope you're all well. It took me a while to record my second video because I had some technical challenges. Um, I wanted to share my iPad screen so that I can draw things and explain and better, but I was struggling to get something which has a cursor or mouse that is shown so that you guys can follow me. So what we will start from today is looking into some basics. I gave my previous video more of a higher level, thing in physical design, but I strongly believe that before we look into details of physical design, we can have a look at some of the basics. What is transistors, how standard cells are made, what kind of standard cells are, and what is timing, what are the basic concepts in timing closure, and what is the technology. So my plan today is to look into transistor and some of the basic gates like inverter and Nand Gate, and we see where we go from there. So let's get started. Let me pick my iPad and start drawing something. Anyway, if you have any questions on this, feel free to add your comments below. And if you think this is too basic for you, you can skip that. I was thinking of for the people who don't have a very good idea of it, or people who haven't done an electronics course before. We talk about the basics here, but yeah, feel free to skip it. All right, so I think what we can start now. All right, so the basic thing in the digital world is sending an information of 1 or 0. Okay, these 1 zeros with the different combinations send different information. So a critical element of a digital design is the ability to transmit a 0 or 1. Once you know it for 1 bit, you can do it for a lot of other bits, and that's how you make your whole digital design, which can generate certain outputs when you have a certain inputs. So it's like a information processor or information consumer or information transmitter. So let's look at this. We have a node, let's call it output node, and we want to send, well, let's give it not O because I'm gonna put 0 here. Let's give it something, let's call it output. Okay, we want to put 0 or 1. Okay, and how we can use it, 0 is like what we call in digital design logic 0. When our circuit is connected to a voltage, a supply voltage, right, a battery, then when a node in the circuit is connected to a supply voltage, then it's 1. And when that node is connected to 0, then it's connected to ground, then it's logic 0. So this is how in digital circuits we make 0 and 1. So we need to have the ability of this node connected to supply voltage. Supply voltage is represented with something like that. And the other point is, this point is ground. So ground is represented something like this, and this is VCC. So Depends on what supply voltage you have in the design. Let's say we have 1 volt. Okay. So what we do is we want to send the information of 0 or 1 at this node. So how can we do it? So we need an ability to connect it to supply voltage or connect it to ground. So let's look into that. Let's say, sorry, I don't want to erase this. Okay, we want to have a switch here. Okay, and we want to have, I think of it. Yep, and this switch is, this switch is controlled with this input. Okay, so when switch is down, okay, then these two are connected, and this node, let's put it, something like this. We put another switch here, and it also has something. Okay, so and this one, let's look into this. So when on the top switch, okay, when it's closed, this point is connected to 1 volt, so it's logic 1. Okay, when the bottom switch, let's call S1 and S2, when bottom switch is on, okay, and the above one is off. Okay, and this one on, this node is connected to ground, so we are sending a 0 data. So I created this circuit just to give you an example of how to send 0 and 1 to a node in digital design. It's so the switch that we have has 3 terminals. So the switch that we use in integrated circuit is transistor. Transistor is supposed to be our ideal switch. So when using a terminal, which we call it gate, okay, using gate, when gate turns on the transistor, it flows maximum current, so maximum voltage is transmitted to the other to the output node. Maximum current means very small resistance, so that this output node is almost equal to 1 volt. And when we close this one, okay, and we switch, when we open it and it turns this off, so there is no current flowing through that line. So again, we expect it. In reality, it doesn't happen, but what we expect with an ideal switch is once it's off, no current flows. Okay, so the output is completely disconnected. So this switch is what I said in our digital circuits is a transistor, and transistor has 3 pins, 3 terminals. The gate I already put there. Then it has drain, and then it has source. Okay, so in this picture I put 2 switches or 2 transistors. Okay, the transistor that is used to connect to supply voltage is PMOS, and the transistor that is used to send 0 to the output is NMOS. Both I won't go into transistor formation or internal working of the transistor in this video at least, but I can record some other time another video which explains that in more detail. But let's for this video, let's think of NMOS is a switch, a transistor, which is really good in sending 0 to the output, and PMOS is made in such a way that is super good in connecting in supplying higher voltage or 1 volt to the output node. Okay, so and PMOS and NMOS, they are created in different way, in different materials they're made up of, and we will look at some other time. So this, now let's look into what the schematic for an NMOS is this. Okay, this is our, let's say, output, and this is ground, and this is our input, some signal. Okay, and what we have PMOS, the circuit for PMOS is this symbol, a circle here. Okay, it's one part is connected to, this is a symbol for supply voltage, and this is for the ground. So this is our PMOS, and this is NMOS. Okay, so let's create a device. Okay, that a digital device that has ability to transmit the inversion of its input. So when at its input, it's a device, let's put it this way, it's a device. When at input is 0, its output is 1, and when input is 1, output is 0. This is another information processor, right? A capability that you want to send the opposite information with respect to the input. Okay, let's call this inverter, and let's see how we make inverter here. Okay, so let's bring the same circuit, both PMOS and NMOS. Okay, so what we have here, let's put okay. This is ground, and this is supply voltage, VCC, 1 volt. I don't know if you can see this clearly, but oops, it's too big. Yep, this is better. This is output. Okay, and let's say this is a signal. Sorry, let's look at it. Let's say we have here a switch and another switch here, and what we have here is, and we control this gate, a switch. I haven't started using a transistor yet. So let's see if we can, change these switches in a way that when, let's say we have 0 here, okay, we connect another signal here, which can produce 0 and 1, means 0 volt or 1 volt. So when we want 0 here, as an inverter, it needs to generate 1 here. So 1 means supply voltage. Okay, so when 0 is here, we want this stop switch to conduct. Okay, so when this node is connected, this switch is on, this is connected to the VCC, and we have 1. And when we have 1 at the input, we want this switch to conduct and the other one to be open. In this way, this node will be connected to 0. And as I mentioned before, that a switch, when you want to connect a node to supply voltage, is which one? is PMOS. Sorry. Okay, and a perfect switch when you want to connect a node to ground is an NMOS. Okay, it's a PMOS, it's an NMOS. So NMOS has the characteristics that when its input as 1, it will conduct. When its input as 0, it will not conduct. And with PMOS, when it puts a 0, it will conduct, and when its input is 1, it will not conduct. Okay, so you can see that by combining PMOS and NMOS in this way, we have created a device which inverts its input. Okay, and this is inverter. So this is which we call it a gate. Okay, typically, people also use gate for transistors, but in physical design, typically when we say it's a gate, it means it's a next level up device, which consists of more than two transistors. So this device has this notation, inverter. Okay, now this is one device which inverts. We can also have devices which can generate different combination of outputs when certain combination inputs at the inputs. So let's look at another device. Let me bring a new layer. Okay, so let's say we want to create something when a circuit or device like inverter before. It has two inputs, A and B, and it has output. Okay, and since there are two inputs, so they can take 0 0, they can take 0 1, or 1 0, or 1 1. So these are all the four possibilities when you have two inputs. And what we want is when both inputs are 0 0, when either of the input is 0, and you see all these have at least one input 0, so we have output 0. And when both inputs are 1, it's 1. So this is another way of transmitting an information that based on certain combination of inputs. Okay, and if you have gone to if you have taken digital design courses, that a device that has this property is called AND gate. Okay, and its notation is this: at input A and B and output is O. Okay, and another device, this was AND. So let's look into another device which I call as opposite of AND, or it is NAND. Okay, when it's the way I remember it is opposite of 1, opposite of AND. So 0 is 1, 0 is 1, 0 is 1, and 1 is 0. But if you look at its relationship with respect to the input, so when either of the inputs is 0, it will have 1. Okay, 0 1, 0 1, 0 1, and when both inputs are 1, it will produce a 0. So it's like a version of AND gate, but it is another device which can transmit a different way, which can transmit information in a different way. And its notation is this. It's like an AND gate with two inputs, and what you do, you put a circle there. So these are examples of some other gates. So we had inverter gate, then we have AND gate, then we have NAND gate. Now let's look at how these are made, right? So NAND gate, let me draw a circuit and you will see. Let's again look at, this is our supply voltage. Okay, and this is our ground. Okay, and this is our output node, right? What we do is NAND is we put two PMOSes in parallel. Okay, both their source is connected to supply voltage, and what we do is we connect to the two NMOSes which are connected in series. Okay, and we connect A to this one. At the same time we connect this one, and let's say this is our second input and the same input is connected to the second NMOS. Okay, and our output is connected to this one. Let's take a look at some examples here. When A is 0 and B is 0, let's pick a different color, 0, B is 0. Okay, so then we have these PMOSes, they are turned on. Okay, and 0, 0 means here our NMOSes are off. So this circuit is completely broken, and we have this node connected through these ones to VCC or logic 1. And you can see that for this node to be connected to VCC, you need either A or B at 0, which is the same condition if you look at this, which is this NAND gate. So if you look at, if either of the input is 0, we will have this, either of these PMOSes on, and this node will be connected to VCC. And if either of is 0, either this is disconnected or disconnected, this node won't be able to reach 0. So for this node to reach 0, you need to have both of these NMOSes on, and both of these NMOSes will be on when they have 1, which is this condition. So this is an example of a NAND gate. Typically in physical design, which is a big block which consists of so many transistors, several 100,000 more than a million transistors. But what we do is we count the overall design side in terms of gates. Okay, and typically NAND gate is used as a standard one. Somebody says, okay, how many NAND gates you have? So we are roughly modeling it that okay, NAND has about 4 transistors. So how many cells or how many gates we have in the design? So this is NAND gate is used as a measuring entity for size as well as area count. Okay, and if you put, let's look into this. If you put an inverter here, again I'll not sketch it because we have already sketched how inverter, it has 2 transistors. Then this whole device becomes an AND gate. So we had an AND first and we inverted it and becomes AND gate. So an AND will be bigger in size than an NAND gate, and it has 2 additional transistors. So yeah, I think this is enough for this video. I hope I was able to explain some of these basics in a way that anybody can understand. If you are still not able to get anything from it, you can leave a comment and I'll get back to you, or I will try to maybe look at more of those preliminary things or basic things in the future. Hope you enjoyed it. Stay safe. Take care. Bye.